Okay, so this is old-fashioned long division, and I hope that you knew how to do this before today, but we're going to, by the end of the hour, make sure that you know how to do long division with polynomials. So what does that look like? I'm going to show you that in just a second, but first let's do a review of yesterday. Do you remember the factor by grouping deal? You can group this into two parts. Divide it like right there. Act like this is a separate problem and you factor it, and then you factor this, and then you put it all together. See if you can do that. That's the main thing I needed you to learn yesterday in the difficult factoring section. Okay, so give that one a try. In a minute, I'm going to ask you to turn it my way and tell me, don't worry about the real roots and imaginary right this second. All I want you to do is factor it. But after that, if you've got time, get the reals and imaginaries. But when you've got it factored, turn it my way and I'll tell you if you did it right. Yep. 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 Shouldn't be a plus in between there. It's a times between there. Remember, it's factoring, so they're factors, so they multiply together to get the answer. Yep. 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 You don't want the I in there in the problem. See, after the 6 you have an I. You don't want the I in there. That's only when you're solving it later. Factoring, in the process of factoring, you don't want the I. Good. 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 Yep. Okay, there were a couple people I may not have seen there, but looked like pretty much everybody had it. The first step is you see what goes into both of those, x squared does, and you have x minus 5. And then you see what goes into both of those, 6 does, and then you have x minus 5. And then you say to yourself, oh, there's an x minus 5 in common. So those come out to the front. And then what's left after I divide everything, if I'm factoring out an x minus 5, what I'm doing is dividing everything by x minus 5. And then this cancels this, and this cancels that. What's left is that, and they go here. Okay, now actually figure out the real roots and imaginary roots, and don't show me because that takes too long, but I'm going to tell you in a second. The real root is simple. I see it just sitting right out here. It's this guy. A real root would be 5, because 5 would make this equal 0. Remember, the whole thing equals 0. So that would be 5. And imaginary roots, that would be solving this part. So take a second and solve that part. Set it equal to 0. Absolute value of x equals square root of negative 6. So if I take the square root of negative 6, that's going to be, well, I can't take the square root of 6, can I? So I better leave it as square root of 6. But I can get the I out of there, because the square root of negative 1 is I. So now I'll have absolute value of x is I root 6. Now how do I finish it? What am I missing that I don't have? Plus minus. So I got to go x equals plus and minus I root 6. So that has an I in it. Therefore, it's imaginary. Plus and minus I root 6. Notice how often I'm pounding on that, because so many kids lose points on what's imaginary and what's not. Just because it is a square root, it is not imaginary. The square root of a negative isn't imaginary. Yes? Good question. I know you saw it on the key after, and we don't like it after generally because it's really hard to see whether that I is underneath the square root or not. Because an I underneath the square root is pretty much almost never seen, and it's not supposed to be under the square root. So usually we put it in front. To be honest, I'm sure that teacher wasn't necessarily wrong by having it at the end there on the key, but I'd rather have you put it in front. But I would not mark it wrong as long as your I is not underneath the square root. Okay, any questions about that? That's the review of yesterday. Now here's me showing you how to factor using long division. And to begin with, here is an example. You could not factor that using divide and conquer, because where would you divide it? You might think you can, but it's not something we can divide right down the middle, and so therefore it's not, the bottom line is it's not going to work. I know you could, divide it here, for instance, and factor out an x out of this, this, and this, but then you'd have a 3-part thing, which would not match up with what you'd have there, which would be a 2-part thing. Okay, so bottom line is the divide and conquer thing won't work on really big ones. It's kind of nifty for 4-parters, but when it's got 5 parts or 6 parts or 7 parts to it, long division becomes your next tool for doing factoring. Okay, so to factor this puppy, so basically what I want to do is factor it into 2 things. Like, x to the 4th plus 3x times x to the, 2nd minus 3x plus 2 or something like that. Okay, that's not the right answer. I'm just saying we want it to be factored. So you can factor it using long division. Just like when you take the number 21 and you say, does 3 go into it? What you're saying is 3 times 7 is 21. I factored it. Right? That's what you're doing with simple numbers. And so if you're factoring a number, you're really taking it and breaking it down into what times what. All right, so now let's talk about this. I'm going to demo this and show you how it will work to see if x minus 1 is a factor of x squared plus 2x minus 3. I don't expect you to learn it from this. I'm just going to show you one quick. Okay, then I'm going to break it down into little steps in a minute. Okay, the first thing I ask myself is, if I wanted to put something here, remember what you do then is you take this number and you times it by that and you put it right here. Okay, that's what we did on normal long division. So I'm going to figure out what to put there to multiply by the x minus 1. And I always want to make this first term match up. So what should I put here with the question mark so that that first term will match up? Anybody do that? An x. Because when I go x times that, I'll get an x squared. But I got to times it by both of them. So I'm going to go x times x is x squared, and x times the negative 1 makes negative x. Now, do you remember in the other process, when we were doing like, 20 and 8 going into 20, we said to go in there 2 times. What we did is we multiplied the 8 times 2 and put 16 right there, right? Same thing I just did. I took this times this and I put it right here. But then you remember when I put the 16 here, I'd always make it the opposite of 16 and subtract it. I got to do the same thing here. I got to do the opposite of this and the opposite of that. I change both signs to their opposites. Because just like this, I'm making a 16 or a minus on my 16. So, all right, so then the x squared and the negative x squared cancel out. And 2x plus x is 3x. Okay. Now, do you remember in long division what to do if I was doing a big one like 203 or something? And I said, okay, it went in there and I got 4 left, and now I've got this 4 left, but I haven't done anything with the 3 yet. Do you remember that you bring the 3 down, and then you say, does 8 go into 43? So I need to bring that 3 down just like that. I need to bring this down. I haven't touched that minus 3 yet, so now I bring it down, and it's part of the action now. Okay, so wait a minute. Sorry, that x needs to stay there. Now I need to figure out what do I put here and multiply by this stuff and to put it there. Anybody got a guess? 3. So I'm going to put a 3 there, a plus 3. And the plus 3 times the x will make 3x. And the plus 3 times the negative 1 will make minus 3. And look at that. Remember, if I added them right now, they would give me 6x minus 6. So I don't want to do that. I want to do the opposite of each. So I make that minus and that a plus. And then that minus that makes 0. It's gone. And that minus that makes 0. It's gone. I have a 0 left. Remember me saying that if there was a 0 remainder, that it worked? Okay, so what did we do? We just figured out the 2 factors of this answer Just get this off to the side here. My factors are this and this multiplied to that. Just like when you're all done with the long division problem, I'll do a simple one for just 2 seconds. Let's say it was 5 going into 30. I go in there 6 times 30, nothing left. That's the sign it worked. And that times that makes that. Okay, that's the big picture. That's where we're going. I don't expect you to understand it totally yet, but you're starting to get the big picture. All right. So if I wanted to do, everybody go to this slide, please. If I wanted to do, is 3 a factor of 22? Okay. I agreed, it's not. How do I prove it? I go 3, 22. Technically, just so you know some terminology, the dividend and the divisor are the 2 parts of when you're doing division. Okay? And the dividend is in the den. See, it's sort of like a bear in the den. All right, the dividend is in the den. And the divisor is the other one. Okay, so this one's the dividend. It's in the den. And this one's the divisor. All right, so then I would, now that you know a little bit of terminology there, just try to remember the bear. The dividend is in the den. 7 goes in here, 21, and there's 1 left. And then, so we can keep it simple right now and just say, did it work? No. So therefore, was it a factor? No. If this had been a 0 at the end, it would have worked, and then these would have been the factors. Okay? All right, on to the next slide. Would you just make me the little picture where the dividend goes in the den, and see if you can do the long division for 7 going into 83. Now, obviously, if you know your math, it's dozens, but I want to know how much is left. What's the remainder? So you should have gone like this. 7 into 83. First you go into the 8. It does go into the 8 one time. 1 times 7, 7. Now subtract them. 8 minus 7 is 1. Remember what to do now? What do? Bring down the 3. And then 7 goes into 13 how many times? Almost 2 times, but it's still only 1. So then you go 7 times 1 is 7, and then you subtract them. Remember, always make this the opposite of what it was. 13 minus 7 is, what is that? 6. And so, for those of you that paid attention at the beginning, you probably remember that the answer is 11 and 6/7. But, more to the point here, is 7 a factor of 83? No. Why? Because there's a remainder at the end. Make sense? This part should feel easy. All right, do one more. 18 going into 288. I don't expect these to be automatic for you. Just like when you get to the polynomials, you have to do the problem to know whether or not it's a factor. A lot of times I can't tell. I have to do it. Do long division, and then I can tell whether or not it worked. Again, I know some of you are used to a different way of long dividing, so it's not going to be easy for you. 18 goes into 28 one time. 1 times the 18 goes here, and then I make it the opposite of what it is. Twenty minus 18 is 10, and then I can't go. 18 doesn't go into 10. It's not big enough, so what do? Drop the 8. Now I can go 18 goes into 108. Again, bit of a pain. 10 times would be 180, so that's way too much. You can just try something. Like maybe I'll try 5. I'm just going to try 5. 5 times 8 is 4D. 5 times 10 is 5 plus 4 is 9. So I had 90. Didn't quite work. Wasn't quite big enough. Should have gone with 6. 6. 6 times the 18. 6 times 8 is 48. Notice how I'm holding a place? Now you could do this off to the side of your paper and go 18 times 6 and do it that way. That'd be fine. 6 times 8 is 48. 6 times 1 is 6 plus 4 is 10. Ooh, 108. Hey, it works. And then when I subtract them, I have a zero remainder, which means 18 is a factor. It worked. What are the factors of 288? 18 times 6, 18, sorry, makes 288. Okay, now, I'd like you to see if you know how to set this up. Not even to do it, just how do you set it up? And put the dividend in the den. Okay, you should have said x minus 1 goes into x squared plus 2x minus 3. Okay, now you're not going to be able to just look at it and go, oh yeah, it does. You're going to start one step at a time. You ask yourself, what should I put here? Anybody know? X. Because we want to know what times x will give me x squared. See, I want this to match up. I'm writing something right here, right? And I want it to match up so that when I take the x squared minus that thing, the x squared will disappear. All it really matters is that it matches up with the very first one. We don't ever look at the second one. We just want it to match the first one. Because we need that to go away. We need it to cancel with this other one. Okay? So, if I put an x here, technically it should be here. It really doesn't matter where you put it up there. But x times the x makes x squared. X times the negative 1 makes negative x. Now, really common for people to forget to change the sign of both things. Change that to a minus and that to a plus. And now I put them together. And now these do cancel, just like I wanted. And that becomes 3x. And then I bring down the minus 3. Remember me doing this one before? So finish the deal. Okay, so you should have put a 3 here, and 3 times the x makes 3x, and 3 times the negative 1 makes minus 3. And I'm okay at the very end if these match up perfectly. You don't have to change the two signs, because we know if they match up perfectly, then that means there's a zero remainder. All right, so then what do you have to do at the very end? The point of this is factoring. The point of this is getting an answer to what are the two things that multiply to this? This is like the problem, and the answers are here and here. And so you should write them together and say x minus 1 times x plus 3. Now you might be thinking to yourself, I've been factoring for a long time. I could have just factored this in my head. That's true. You could have. But we're trying to teach you these problems with easy problems. We don't really want to start with the 7-part one because that's going to be way harder. So yeah, I mean, when you teach a kid how to multiply, 22 times 3, you could just do it in your head and say, oh, it's 66. But you want to teach them on small, easy numbers so that when you get to the hard ones, you can still handle it. Okay, so I know you could have just taken this and said factor it, and it would have come out to that and that. And that would have been an easier way to do it. But I'm teaching this process of long division on easy problems. Okay, try doing that one without any help from me. Put the dividend in the den, etc. I'm going to pause for a second while you give it a try. All right, let me show you how this one would have worked. Should have said x minus 3 and then x squared minus 7x plus 12. That makes this the dividend and this the divisor. All right, so then I'm basically trying to figure out what up here would multiply with this down here to give me that right there. All right, that's kind of the big picture. Now I'm going to try to find something that matches up with this first term. That is the hardest part of all. If you can just get started on it. My dad's saying was, if you get started, you're halfway done. And he had a point that, you know, because once you get kind of over the hump of getting going, it's not that hard from there. So I'm going to put an x here, and that makes this times this match up with this. So x times x, x squared. X times the minus 3, minus 3x. Now I make this opposite and that opposite. That's a really common mistake people make, is not remembering to make them both the opposite of what they were. Now this cancels, and this part here, remember, if we made this the opposite like we were supposed to, is a plus minus 4x. Then I bring down the plus 12, and then I say, what should I put here? Well, I needed to match up on just the first term. So I put a minus 4 here. That way, when I times it by the x, I'll have minus 4x. And minus 4 times the minus 3 is plus 12, and look at that. It worked out perfect. I got 0 remainder, and there are my two factors. X minus 3 times x minus 4 gives me the original problem, which if I move some of this chunk off to the side over here, the original problem is more visible right there. That times that makes that. Do you get it? Cool. You just learned something that your parents probably could appreciate, because they know how to long divide. You just remind them, like, you know, you just say long divide. And I think many people will have never seen that you can long divide with algebra. It's kind of cool. All right. So I just want to remind you again, obviously, we don't have to use long division to factor this. We're using trinomials to understand it. As soon as we can do this, we can do it with 5, 6, or 7 terms. So I know you could just factor this, and it would be easier. But you're learning how to do this so we can do it on great big ones that you couldn't do in your head. So try this one more time, hoping that you've got this nailed down. I'm going to pause for a second and give you some time. Okay, let's see how you did here. X minus 2 goes into 4x squared plus x minus 14. That one is a little bit, looks like it would be a little bit of a pain to factor, like if we did it the old school way. It's got a 4 in front, but this won't be that bad. We're going to put a 4x on top. That way, when I multiply it by the other x, I'll get 4x squared. See? That's all you really got to do is match up that first term. 4x times x would make 4x squared. Now I'm going to do 4x times the minus 2, and that's going to make negative 8x. Then I go through and say, okay, opposite of this, opposite of that, these cancel. It's 9x. Then I drop the minus 14, 9x minus 14. Now I got to make just this first term match up. So what should I put right there? A 9. And then I'm going to go 9 plus 9. 9 times x is 9x. 9 times negative 2 is negative 18. Do they match up? No. So you can just stop right there. We don't even really care what the remainder is. Actually, in pre-calc next year, if you go to honors pre-calc, they're going to take the remainder. I'll just show you one quick just so you know. If I do the opposite of this and the opposite of that, then these would cancel, but I would be left with positive 4. Then, believe it or not, it's this times, remember how we do the other ones? 4 over x minus 2. This times the remainder part that goes with the other part gives us this. But all you're going to have to say, I'm trying to, again, teach you more than you have to know, and that way, if you just remember the easier part, feels easier. You don't have to do anything with that 4. You can leave it alone. Just know that it didn't work. So is that a factor of that? No. And if it had been a factor of it, you'd have written that times that as your answer. Okay, but it didn't work, so we have to say no. All right. I don't think we need to do another one. I think we've practiced this enough in class. I know some of you are probably still getting one wrong here and there, but there is going to be another kind, though, that's going to get uglier. And I want to show you that kind. Yes?
If you get, say, like x squared plus 2 as one of the factors, should you take out the imaginary, or do you only
we aren't going to ask you for solutions today. You make a good point that if your answer was this, okay, if all we want right now is does it factor? Done. You're right that this does have imaginary answers, but we don't care right now what the answers are. We just want you to factor. It's hard enough to factor these things. I'm happy you're thinking about that, but you don't need to yet. All right, so this is a different way to ask the question. You get what's different about it? It says, is x equals 2 a solution to this? Okay, well, if x equals 2 is a solution, then all I'd have to do, really, is take 2, stick it in here, and see if it all multiplies out and makes 0. See, it says it equals 0, right? That's a way to do this problem, but that's not what they're really asking. They're really asking you to do is long division, where you say this kind of thing, and then in here you have 2x to the 4th minus 3x to the 3rd minus 5x squared plus 3x plus 6. Holy smokes. Okay, but what do you put on the outside? You don't put x equals 2. X minus 2, very good, because if x equals 2 is the answer, the factor for that would have been x minus 2. Do you get that? X minus 2 would give you the answer of 2, right? So then, if they tell you x equals 2, you got to know to use x minus 2. Okay, for those of you that are good at this, it shouldn't be that bad. I'll start helping fairly quickly here. 2x to the 3rd times the x would make this match up. 2x to the 4th, right? And 2x to the 3rd times the negative 2. That makes negative 4x to the 3rd. Then I got to remember to switch both signs. Then this and this together make positive 1x to the 3rd. Now I have to drop down a term. Minus 5x squared. Now I have to figure out what to put up here again to multiply by the x to match up with this x to the 3rd right here. So I would want an x squared, because x squared times x makes x to the 3rd. Got to remember to change the signs. Worked. Awesome. I'd almost be kind of proud if I can't show you all of the problem on one screen, because that's how big they are. So did it work? Yeah, I got a remainder of 0 at the end, so it worked. So is it a factor? Yeah. Is x equals 2 a solution then? Yes, because the factor that goes with that is this. So the factored answer is x minus 2 times 2x to the 3rd plus x squared minus 3x minus 3. Whew. Remember, this test is until Wednesday of next week. Got some time to learn this. All right, so what if there's missing terms? That's the last kind of problem that I have to talk you through. And is 2x minus 5 a factor of that? Well, I can't just slap it in like this, 2x minus 5 and 2x to the 3rd minus 9x squared plus 15. Something's fishy about this one. What's different? What's weird? Mr. B?
Would be that there's no x.
Yeah, there's x to the third. There's an x to the second. There's no x to the first term. So to make this work, to make everything line up, you have to go plus 0 x's plus 15. And now the problem will work. Believe it or not, if you hadn't had that 0x in there, things would have gotten all messed up at the very end of the problem. We've been like, wait a minute, it's not matching up. It's not lining up. Okay, so if there's a missing term, you just put in 0 of them. It's got to have that to hold the place. Now it just works like all the other ones. No big deal. All right, so this one, missing term or not? Yeah, you can quickly look through and see. 3, second, first. Yep, there's no missing terms. No problem. That'll work fine. Okay, this one, missing term or not? Yeah, that is a missing term. All right, on tonight's homework, it's in the normal spot. Just do the evens of the problems because I've given you no work time. Just do the evens on tonight's. Have a good day.